Welcome to Web Handling. My name is Dave Rysam. I am super excited to continue our Material Matters mini-series with a discussion of web and roll length. Why, you say? Because length is widely reported, yet very poorly understood. I know your time is precious, so let's get started. So, what is length? Recall from our last clip, Web20169f, that there is no such thing as width except as defined by a specific test protocol. It is even worse for roll length. There is no test standard or even a near universal practice. Thus, when and where and how you and your customer measure length will all affect the values that you each get. Differences in the detail of how you and your customer each measure length can result in customer-supplier disputes. Before we detail length measurements, let's talk about some commercial practices that would be commonly found in purchasing agreements or on wound roll labels. These quantities have statistical and legal importance, even if they are merely being reported. In the paper industry, it is common to wind to diameter, report length, and sell by weight. In the converting industry, by contrast, it is more common to wind to diameter, sell by length, and report weight. Note that in both scenarios, length is important, if not vital, for you and your customer. Note from the last slide how both diameter and length are either reported and or guaranteed by contract. However, specifying both diameter and length at the same time is overconstrained by the laws of winding physics. It is so risky that very few product lines do this. Consumer rolls of bath tissue and kitchen toweling are a few of the products that do this. However, even with decades of experience and even with a compressible product, tissue manufacturers can still run into problems here. The reasons for this are a bit more involved than we can cover here. However, we do that in great detail in my award-winning and trademarked Web 101 winding course. To make a long story short, there are 3 connected wound roll parameters: diameter, length, and tightness. Fix any 2 parameters for a given incoming web, and the 3rd parameter becomes unchangeable. To get around this, we can fix 1 to tighter specs and let the other 2 float within some hopefully reasonable range to accommodate incoming web variability. With this background, we are now ready to tackle roll length measurements. There are no less than 6 totally different ways to measure length, and each one will give totally different answers. Also, there's a very large difference in accuracy and variability with each of these methods. They are listed in order of very approximately worst to best. A simple, but not very accurate method is to calculate length given roll weight, width, and basis weight or bulk density. The free and easy wound roll sizer by Abbott Apps can do this and many other similar calculations. However, the problem here is the uncertainty of basis weight or bulk density, which could vary by a few percent and still be in spec. Another simple, common sense, but not very accurate method in general is to count the sheeted products in a row. The reason for this may become clearer in the next slide. The common footage counter running on the product is also, in general, not very accurate for reasons too technical to cover in detail here. Also, this footage counter may mark the web. It gets in the way of the operator and is not very mechanically robust. Slightly better is counting roller or motor revolutions. If for no other reason than the counter will not mark the web, will not get in the way of the operators, and is rock solid reliable from a maintenance point of view. Still, it is not a perfect measure if the web is thick, if the web is stretchy, or if there is web roller slippage, which, by the way, can also happen on nipped footage counting reels as well. Finally, the very best in terms of accuracy, if there is such a thing for length, least variability, and most reliable is LDA, or laser Doppler anemometry. This non-contacting light sensor can often have less than 0.1% variability. Still, even if our sensor were absolutely perfect in every regard, including accuracy and variability, we would still have length discrepancies between us and our customers, as we will see in the next slide. There are many reasons why length measurements may not yield consistent answers. Some have to do with the mechanics of the instrument itself, such as we outlined but did not detail in the last slide. Some have to do with operational considerations, such as when is the footage counter enabled and disabled? For example, is the material removed at the top of the roll accounted for or not? For example, is the material passed during threading counted or not? For example, is the small amount of material often left at the core accounted for or not? Then there are material mechanics behaviors that mean that length will be different even when measured on the same roll with the same sensor. For example, if the web is stretchy and one person measures the length at a tension of 10 and the lab rolls it out under a tension of 0, both will get different answers. Then there's changes in moisture and temperature, which also affect length. Finally, changes in length with time are common with materials that creep or materials that crystallize or cure, such as film or rubber as examples. As a consequence of the many potential issues just listed, supplier-customer disputes for roll length are not uncommon. If suppliers are faced with a dispute, the first response is often to pad the roll by adding extra length that's actually not charged for. This is a less than perfect economic solution because the best solution is for both of you to get the same values for your measurement of length. In order to resolve these discrepancies, someone needs to go through the previous lists item by item and check in detail each potential source for its possible size, procedural differences, and variabilities. There are 3 starting points to learn more about roll length and many, many other web and winding concerns. The first is the must-have Ultimate Roll and Web Defect Troubleshooting Guide by Tappy Press. This is an encyclopedia of 500 defects and much, much more. The second is the must-have 750-page Web Handling Handbook. We have an entire chapter on material properties, and an entire chapter on winding, and many pages of test standards in Appendix T that would be helpful for quality control, troubleshooting, and web handling work. More details can be found on the link below as well as in the show notes. Finally is my award-winning and trademarked Web 101 class that has been taken by about 5,000 people, just like you. Here you will learn about webs, web handling, winding, converting operations, and much, much more. Thank you so very much for joining me in this Material Matters series. Stay tuned for the next clip where we will talk about another most important web property, roll diameter. If you found a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. Please also consider supporting the work of this channel using the Patreon link below. See you next time.